Hi, Jessica.
Efficiency aparecendo que é linha.
Hello, everyone.
Jessica
Hi, Jessica.
Hey, can you guys all see my screen?
Yep.
Okay. Yes, I'll start. It looks like we don't have a ton of people. It's recording though, so. The class today is going to be creating a parametric detail in Revit. Specifically, it's going to be a perimeter detail, but you can use the skills to do all kinds of stuff. So first, what is parametric? So you can see in the slide, I just copy and pasted what Autodesk describes parametric as on their website. So they say the term parametric refers to the relationships among all elements of the model that enable the coordination and change management that Revit provides. And then they use a couple of examples. One example would be the outside of a door frame is a fixed dimension on the hinge side. So if you move the partition, the door retains the relationship to the partition, or the edge of a floor or roof is related to the exterior wall, such that when the exterior wall is moved, the floor or roof remains connected. That is an example of a parameter of association or connection. And they didn't really include this in their examples, but you can also have parameters that it just means that you have information attached to something that is kind of in the background that you can make use of. So if you guys want to read the whole list, you can go to the Autodesk website and just search for what is parametric. So what are the benefits of parametric details? So you can create relationships of association and connection. So that's what I'm going to be demonstrating today. You can also include information that will be automatically updated in schedules. We already do that with the Gen Notes. You can create libraries with information attached to 2D and 3D components, and we are already doing that with the new method of tagging. We have information attached to our 2D components. You can reduce the amount of work needed to be implemented when there are design changes. You can attach 2D parametric families to 3D parametric families, and I'll show an example of this from Stevens Creek. You can create flexible details that are easy to update and share across different conditions and projects. And once you make a good family, it reduces the work to eliminate the vary. So what I meant by that is on the takeoff side or project checker side, they always hate when we have details that will say varies on them. And we do that a lot of times because we make a 2D detail and like we might know that this 2D detail needs to be used in these like 10 different conditions that we're showing on our plans or on our elevations, but it would be a lot of work to manually adjust the 2D detail to all those conditions. So we'll write varies. But if you're smart about making 2D families, you could get rid of a lot of those conditions, because you can make a family that it's just as easy as like typing in a number or a value to show those different conditions. And then we could reduce a lot of those varies dimensions in our details. And then you can also organize options by instances or by types, and I'll talk about that a little bit more. Then what are the challenges of parametric details? So first, they require a high or intermediate level of Revit expertise to create. So they really require some training and some experimenting. In order to share them across all projects, we will have to devote the time to creating standards, and we need a method for creating, storing, and editing the families, because currently it's just not part of our process to be sharing these across different projects. Users don't always know the limitations of parametric details or families. If someone else made them, they may not realize what wasn't accounted for, and they can break them. And that's something that can be minimized with testing and refining the families. And then Revit 2D families can contain taggable elements, but you can't actually make a 2D family that has all the tags in it. So they'll always have to be retagged when they're placed in every new detail. And then what are the alternatives? So currently we use groups, 2D line work, and really simple parametric families to create details. And pros of this method, Advancer can create the details from CAD details at the beginning of the project, which reduces the labor required from Walters and Wolf drafters. They're easier for a beginner to figure out how to create and edit. And the groups can be used by, in more experienced Revit users can use groups to copy and paste repeated elements, and then they can edit those groups to update all instances. And groups can contain tags, unlike families. Cons are that currently we're not reusing the perimeter and other detail elements across projects, and partly that's due to Revit versioning issues. When you have to update details, it can sometimes actually take a lot more work than you would anticipate when they're made just from like 2D line work and different families. And then Autodesk actually doesn't support groups very well at all, and groups can be really buggy and they can break. So it's not great to be relying on groups. And then Revit users, especially more novice Revit users, might update a group without realizing it's in different places in the project and will update all instances. And then groups aren't parametric. And so when I get into the demonstration, you'll see some of the power of a parametric 2D family, and you just can't get those same, you can't do that with groups. Okay, so now I'll get into my demonstration of how to create a parametric perimeter detail. So this is the image of Matryoshka dolls, and you can kind of think when you're creating one of these families that you're going to be basically nesting lots of different elements. You can nest elements within a family, and then that family gets put into your project. Okay. Okay, so here I have an example of two versions of basically the similar details. One is parametric and one is like our more traditional process. So this is just made with detail lines. So this parametric perimeter detail I already made. And basically, the idea behind this is creating associations and relationships. So I have a curb in here, this insulation, this interior finish, slab, terrace, and they're all have had their relationships to each other defined, so that if I move like this gypboard, it's shrinking this insulation. I can move this edge of slab in, and it drags the terrace with it. So one thing I did making this is I set the curb width to actually not be something that changes by dragging. You change it by inputting a value. So I can set my curb width to be like 6 inches now, and it's going to grow this insulation to fill that gap. I also have some options to change what's out front. So it can go from terrace to this ACM panel, sloped ACM panel, and can change from a curb to a slab. So in one family, I can have essentially 6 details, because I've got 3 options for what's going on out here, times 2 options for what's going on back here. Well, even more than that, because I can change the relationship from the face of system to the curb for everything. And then compared to our traditional detail, which is just a bunch of 2D line work. So over here, if I have a 6-inch curb and I realize, oh, that's incorrect, it's supposed to be wider, have to drag the curb, then I'll drag the insulation. If I realize, oh, this is incorrect, I'm showing terrace out here, I should be showing that it's the ACM panel. Well, I have to go to another detail that has the ACM panel, copy, paste it into place. If I realize the face of this curve is wrong, it should be 2 inches back, I've got to just manually adjust that. And it doesn't really seem like, a crazy amount of work, but it can kind of add up when you have a lot of different details and perimeter conditions. And also you can make mistakes pretty easily. Whereas once this family is made and it's made well, and you just have values that you're changing. So for my concrete offset, I can just type in 2 inches and it's going to be correct. Two inches. So what I'm going to teach you guys how to do is to add an element to this detail. So down here, I'm showing another condition that I haven't built into the family yet. So we're going to make this little panel and build it into the family. And so one thing about this panel is that it's actually going to have to vary in height. So with the old 2D process, if we had 10 different instances of this panel at different heights, it would probably be too much work to be making 10 different details where the only change is that you're dragging this panel up and down. But if you make it parametric, it would be pretty easy to just copy 10 instances, adjust the value, and you just have them there. So, okay. So first, I'm going to select my perimeter condition and then go to Edit Family. So now you can see the way that, so here's our first layer. So the way that this family is made is that actually all these little different elements I could turn on and off and manipulate are their own families within this perimeter condition family. So to make that panel, I'm going to create new family. And then Revit has a couple of default templates that we can use, but they don't have all our standard hash patterns in them. So I'm actually going to go to the WW standard template library and grab the mullion detail item template. I'm not making a mullion, but the template will work for this, and it has our standard hatch patterns in it. So we'll click open. So first things, I need to name this, I need to save this as something because that's how I'm going to give this family a name. So I'm just going to save it locally in my project. Okay, so now I need to plan. So if I come back and look at what I'm trying to create, so probably I need first think about where my insertion point is going to make sense to be. Probably just at the face of this curve, because the dimension from here to this upturn of the panel is going to remain consistent. Actually, that's not true. So because this curve needs to be able to grow. So my insertion point actually should be the face of the panel. So I'll come back to my family, and I can start creating this. So I'll select a filled region and WW aluminum. Oranges. I'm going to go back real quick. So one downside of having something drawn in like the 2D drafting view that you're trying to move to families, you can't copy and paste from a project to a family. So if I want to like get this line work for reference, I basically have to export as a CAD, and then I can import it into a family to reference. So, which I don't really want to do. 2 inches and 9/16.
You use the break shape generator in the family file?
Yeah, I can. So
Okay. Wasn't sure.
yeah, you can use the break shape. Well, I think you can. I guess I haven't tried it since it's new, so we'll try it right now. Oops. Just a second. Me going to double check my (1/16). Okay. So basically, I just have my line right now for my break shape. So then I'm going to use this break shape generator, which I hope will work in a family. Cool. Yes, it did work. Thanks, Alan. Okay, so now I need to build some options into this. Really, the only thing I need this family to do is grow and shrink. So I'm going to create a reference plane, and I can name it. It will be bottom of panel. And so when you select a reference plane under properties, you can set this is reference option to a couple of different things. And basically, if you have a reference plane and then that reference plane is attached to a parameter, and then that parameter is an instance parameter, that means you get a toggle once you're in your project, in your drafting view, that you can move up and down. So I want this to be a reference, and I can even just say it's going to be the bottom. So now I'm going to activate the dimension command, make a dimension, and this is coming from my center reference plane down here, and so now I can make this dimension into a parameter. So if I select it and then click this create parameter option, I'm going to make this an instance parameter. So once we get the family back into the project, I can kind of walk through the difference between a type and an instance parameter. I'll name it metal height or panel height. And we're not going to do this for right now, but you could turn this into what's called a reporting parameter, which means that it's just reading values. It's not really letting you change stuff around. So if I wanted to make a family where I could make like 10 different versions of this panel height, and then be able to put that in a chart, like, oh, I need the panel at these various heights, I I can make an instance parameter for panel height, and I can make a reporting parameter that's reading that same value. So right now, the only thing that is moving is this reference plane. So I need, oh, it's smarter than I thought. Well, I need to make sure that I tie this panel to the bottom of the reference plane, the value I want. So now I can just, you know, I have this set. So as this reference plane grows, it drags the panel down. And actually, I didn't even really need to do anything because Revit's pretty smart. But if Revit wasn't like locking on to this hatch pattern, what I could do is come in here, and I know that this dimension is going to be 1/8. So if I make a dimension and then lock it, that's going to keep this relationship the same. Then I could lock this bottom panel to the reference plane, so that then when I move this, it would know to drag this guy down, and it knows to keep, you know, all the relationships. You sometimes have to experiment depending on how complicated the shape is. The shape's really easy. So now that I've made this, I'm going to load into project and close, and I'm going to load it actually into my perimeter condition family. Okay, so if I place it, so now I've got a family that I can toggle, but I need to build it into this relationship with the slab. So first thing is I made an instance parameter for this brake metal family, but now I've put it in another family. So I need to make that parameter again. So if I select this family and I come over to properties, my one property is this panel height, and there's this little gray box. If I click that, now it's going to open up a box to let me associate family parameter. So I can select a new parameter. I want it to be instance parameter, and then I'll name it panel height. Okay. And the other thing I want is I want to be able to turn this panel on and off, because it's going into a family that already has 3 different options for what's going on at the front of the slab. So I select it again, and then I go to where it says visible, come to the gray box, select new. Also, this will be instance parameter, and so I'll name it brake metal. And then here, so really we kind of want to like organize everything in a way that's kind of easy for users to figure out. And it's a little tricky with Revit because they don't let you make new categories for what you want to group your parameters under. So I have this selected as other. Okay, so if you go to this family types option up here and click on it, we can see all the parameters I've built into the project. And I kind of tried to come up with the best organization that I could with not being able to make my own categories. And so I have, well, all the dimensions are easy and they go under dimensions, but the ones that are going to be applying to multiple instances, I capitalized. If we do this for more projects, we can come up with a system that makes sense. And for brake metal, actually, it should be in the visibility parameter and capitalize, because that's what I did for the other options. Oops. Okay. Okay, so now I have this as a parameter that can be turned on and off, and also the height can be adjusted. So now I need to move it to the right spot. So right now in my family, this is the this reference plane is aligning with the face of glass, and the panel is actually always supposed to align with the face of glass. So that makes it really easy to place it. Let's move it down. So move it. Since this is like moving up and down per the parameter within its own family, basically wherever I place it in reference to these reference planes, it's going to stay there. So I've got it in place up at the top, and then if I just want to be confident it's not going to move anywhere, I can lock it to that center reference plane. I've got it in here. Now I can load into my project on the west side. Yes. Okay, so now it's in here. Let me go up to one that doesn't have anything else going on. So now it's an option that I can check, and I can adjust the height right here. So you'll notice I can't toggle it like I could before. And that's because I made a mistake when I was editing this family. So if we go back to edit family, what I forgot to do was to make another reference plane. So once we moved it in here, oops, if I want this to be able to move up and down like I was showing before, I've got to make a reference plane in this new family, which I will name bottom panel, and then I can make, activate the dimension tool. So this is a little tricky because I actually need the dimension tool to come from the insertion point of this, from the top reference line of the family now down to this reference line, and that can also make that dimension, and then I have it selected, and I actually don't need to make a new family, a new parameter like I did before. I can just drop down this label and find that panel height. Oops. Well, something got messed up. And this is why it's one of the challenges. Can be really tricky sometimes. Oh. This, just a second, I'm gonna disassociate it. And I will use the align tool to lock these and see if it fine with that. No. Okay, sorry. So I was like snapping to some wrong things and it was causing it to be over constrained. Sometimes you just kind of have to experiment. So now we have the parameter tied to a reference plane. So when I load it in, cool. So now I have a toggle I'll be able to grab to move this panel up and down. And then it's also and I can build smarter associations. Like I could tie the bottom of the slab to the height of the panel if I wanted to, so I wouldn't have to adjust both of them. And so the thing is that since this is an instance parameter, I could make like one version that I know the panel height's only supposed to be 3 inches, and one version I know it's only supposed to be 6 inches. And I mean, making that change is as easy as putting a number in. And right now this is really simple, just the shape, but I could include this splice. I could even include the little Z-clip and the fasteners and the caulk joint. All of these could be put into this panel and given relationships so they move up and down. And then another benefit is if, you know, I make a bunch of details showing this panel at different heights, and I need to update it later if the return leg changes or the slope changes or the thickness of the panel changes, I update the family, load it back in, and that's gonna update everywhere, but it will keep those whatever parameter value that I had inputted. So does anyone have any questions on this concept for like 2D parametric families? No.
So just so I understand the concept, so the work planes are really the thing that drive things. You draw your geometry, but you tie it to the work planes, and then the parameters drive the work planes, and the work planes drive the geometry that you tied to it, right?
Yeah, that's a really good description.
Kind of the fundamentals of it. And then you can nest families inside of other families. So as long as you have access to those original families, you can make small changes. So if you find out later that panel wants to go in and out from the concrete, you could add a feature for that.
Yeah.
And that would have that feature, and anybody else who uses that detail, you know, down the line, be able to also edit that feature, right?
Yes. So yeah, so the families are nested within each other, and you can always update the base family to change it to add options to it. One thing is that once you've got something like loaded into your project, and if you go to edit family, you could save it. Like you can save it locally and then bring it back into your project, and it will overwrite the instances. If this was something that someone was like working on just for their project and they wanted to make a little change, like they could just make that change without it saving back to the server. But if we were going to implement this, we'd probably want it to be shared with everyone. So find some way that if people are changing stuff, they're changing it back to the server, and we've got some versioning going on too.
Yeah, and a bit of a naming convention too. So like you said, capitalized means one thing, you know, camel case means something else kind of thing, right? So
Yeah, and I'm sure if we were to implement this, we could come up with a better naming convention. Yeah.
no, it's a great explanation though. Thank you.
Cool. Anybody else? Okay, and then I'm going to show you guys an example of how I tied a 2D family to a 3D family for Stevens Creek. I won't walk you through all the steps, just kind of show it as an example. So can everyone see the scaffolding on my screen right now?
Yes.
Okay, cool.
Yep.
So in Stevens Creek, we had this like crazy scaffolding that we had to build to support this panel fin, and there were these braces built up within the scaffolding, and so I wanted to come up with a way that I could model all those braces easily and also detail them. And I didn't want to have to draw a bunch of details of the braces manually, because that would take forever and I'd probably make mistakes. So first I made like a 3D family for the brace. And so it's pretty simple. You've got, this is an extrusion, and it's just kind of describing the different tubes. And if we go to the floor plan, everything was built with these reference planes and these parameters describing the geometry. So once we built this and put it in our model, we just could use the toggles or use the values to move this brace in and out and to move this brace in and out. And then the other thing with this brace is it didn't occur everywhere. So it additionally had a visibility parameter just to turn it on and off. So first we made just the 3D model, then we had to make details. So this right here is actually just a 2D line work detail. So if I hide it, this is the 3D, really simple, like rectangles. Then here's the line work, and that was a family made kind of like with the methods that we just talked about. And there's a couple of different nested families in here, and they're tied to reference planes with parameters. So that I made that and then loaded it into the 3D family, locked the reference planes together where they needed to be, and see if we can, if I move, change this dimension. Oh, I'll go back into my project and change the dimensions. But basically, oh, you can see. It's all tied together so that once we had this in the project, we modeled our braces, and then we made just each live cuts where we're able to dimension like every we were able to show in 2D all the different braces, but we didn't have to repeat this line work over and over and over again. It was just built once, and then it came in with those live cuts correctly. So it's just an example of how you can use parametric families in a way to reduce having to do a lot of work. And then later in the project, so initially the connections between these tubes changed a couple of different times in the project, and it wasn't really painful to update them because we just had to update the families once to update like all the details. I don't even know how many of these details we had. The only thing that we had to keep updated is we had like one detail call out that went somewhere that actually had annotations. But in the overall live cut plans, we just didn't include those annotations. So here I can show, if I wanted to mess with this, I can show how it could move. So it's pretty cool. Does anyone have any questions on this type of integration? It's a little bit complicated to teach in a 1-hour class. So. Okay. So then my next thing was going to be example of a parametric Boolean family. So right now, this isn't something we can really do. This is just kind of an idea I have for maybe in the future. We can adjust our process to include something like this. So right now, this is like a kind of custom family that I made. And at the moment, if we had like this family, but without a angle on the back or without a pocket filler or something, it would necessitate a bunch of different families to create this. And so my idea is to go into edit family, is that you could come up with, you could basically place all the parts and pieces that could be tied into like this W105120 mullion. You can kind of figure out in the beginning of a project everything that might be with the W105120 mullion, and you can nest them all in one family, and you can break everything up into families. Like right now, if we have a family with door notching, I think we're recreating that door notching every single time for those families. But the door notching could just be a family that gets nested into the family that needs to have door notching and can be turned on and off. But so here I made everything be not an instance parameter like last time, but I made all these parts be, if I edit it, you can see it says a type parameter. So once I go into the project, before when I clicked on something, well, these are instance parameters, so you can see them right now. You could just click a checkbox under properties to turn something on and off or to adjust the values. But with a type parameter, you would basically click on your family, go into edit type, and then that's how you would turn things on and off by clicking in here. But you can take one family then and you can make a bunch of different types. So this family, I made a couple of types just as an example. So here, if I change to captured mullion 1, and okay, so I've just got just the captured mullion. Like, let's say I didn't have included in my project for whatever reason this piece, but with a little angle, like we could possibly have some process where I could just duplicate this family, make it captured mullion to select my angle, which is his own family with the data in it that says if you have an angle back here, it's this part with this fastener. And now I've got a new, what would have to go through family process, but it's a new family. Or if I want it to be captured, mullion, pinned with angle, but then just change this into like extended cover. I can turn these values, on and off, and now I've got this new guy. So this though is still just a concept at this point. I haven't worked through all the kinks. So does anyone have any questions about any of the 3 things I talked about?
Are you thinking about that for like a detail family kind of thing?
Yeah, for a detail family. I mean, I think talking to Zach that he could have some way to change stuff in the model that would then tie into these changed detail families. But if we had a tool making this, the tool could sort of generate random, according to our naming convention, new values for these types. When we had the old glass family, each glass panel was a unique number. And there was a tool that generated the glass family and then saved that data back to the server. So to me, you could just do the same thing with mullions. Just kind of say, okay, well, you're taking these and combining them and then save it back to the server. So then if anyone does that same combination in the future, they'll just be taking that type that has already been created. I think we could figure out how to make it work. It just takes some experimenting.
Yeah, I think that was born out of a situation where you had one detail in your model in a bunch of places and in the shop drawings, and then somebody came along and said, oh, we're changing all of this stuff. So you had to go swap out all the families, update all the details. Whereas you could have just went to the detail, clicked a couple buttons and gotten the changes you wanted, right? That's the idea. Yeah.
Yeah, and part of the thing to me also is that it's just a little crazy to me that if we're applying an angle to, like we're applying an angle to this piece and it's a captured, just like a normal captured face cap or an extended face cap, the data is going to be exactly the same for applying this angle. Really? So why does that require all these like unique families when it could all be built into one?
Yeah, I think for a lot of the things that we do, like that are fairly, like we do a lot. It could be definitely nailed down. It's sort of like, okay, every time we make a jam, just add an angle at the outside, an angle into the inside. Like these are the things we do. You know what I mean?
Yeah.
So you have the options to turn on and off for sure. So. And then we have to figure out how to get that to tie into what the takeoff group does. But like Zach said, I think it's doable. So since we only have a few minutes, if somebody wanted to learn what you've learned, like how did you learn this? Like what do you suggest if somebody wants to learn how to do this? Like what process did you follow?
Well, really just experimenting. That's the #1 thing. I just experimented with different things. If I ran into a sticky situation, I would just use Google or YouTube to help. Another way to learn a lot of things is just once you get the architect's models, you can kind of just go in them and start looking at their families. I've learned a lot of stuff just from seeing what they did. And sometimes the stuff they do is not very good examples, but every now and then you'll see something really smart. So you can get ideas from that. I never watched a class that kind of taught me to do this because I think they're all either too specific or too broad. Yeah, I would just say experimenting, like start small with making it maybe like a really simple family, like just that panel that grows, and then experiment with nesting that into more complicated families.
Mhm.
Okay, anyone else have any questions?
Jessica, I have a general questions. You know, I'm very new on Revit, and I manipulate a lot. Look around, like you teaching me before, and also I learned the first lessons with Amy today. I just ask very just beginning questions. So I know how the link model, like you said, the specific training usually is either too specific or too broad. So it's not exactly what I'm thinking. So Revit is very smart. It's really, they actually, people, how you use Revit is based on people, how you logical thinking over there. It's really, even when I ask question, maybe it's not exactly describe what I really wanted. I realize that it's so specific, this, because it's so smart, this software. So
Yeah.
right now, I'm really trying to get into that as a usually, like really use it. So first question, so when you usually build a model, I'm trying to learn from specific, like simple from a sales model. I try manipulate with a sales model right now. So usually when you build a model, you actually start by link architecture model over there.
Yeah.
So how you to turn all these things off? You have to get into all that, turn everything off. You only leave whatever you want. If you couldn't do it, you only can trace the line. Is that correct? How do you do it?
Yeah, well, when you're bringing the architect's model in, are you talking about like trying to look at how the architect's making things, or just, well, for me, I just open the architect's model just myself, just to learn. It's not really for any like purpose, like, it's not necessarily just because I'm trying to steal their stuff for work, or I'm just opening it up just to break open their assets, just to learn from them.
I see.
It's not part of like our normal process, but you can always just, once they share the models, you can always open them up. You don't have to necessarily be referencing them in.
Okay, cool. Okay, great. Thank you.
Okay. Cool, everyone. Any other questions? We have 2 more minutes.
No? Great job, Jess.
Thanks.
Yeah,
Thank
that
you.
was very, very informative. Thank you.
Thank you.
Good job. Thank you.
Thanks. Bye,
Thanks,
guys.
Jessica.
Bye.
Bye bye.